Hello, everyone. This is Charlie Rose, remaking Dr. Seagrave's refinance model with a $300,000 home, 90% loan to value ratio for a $270,000 loan, 6% rate, 30-year term. First, we need to calculate our payment. Oops, made a mistake already. There we go. All right, so we have our monthly payment here, and that is why I added in the divided by 12 and multiply by 12 so we can get everything at a monthly level. Another thing Dr. Seagraves had done is put in an annual payment, which we can get from our monthly payment multiplied by 12. So now we have our annual payment as well. Just something to give us a little bit more insight. So we have a new situation, which is to refinance after 8 years. First thing we need to do is find the balance of our old loan from the information above. The way we can get that is by putting in the present value for the information above here. And what we'll want to do with the number of periods is take, well, the first thing I need to do, I should probably back out there, put in my parentheses for some easy math. So we're going to take the 30 years, subtract 8 years out, multiply that again by 12, and then we need to add in our payment. Oops, sorry, left out my ending parenthesis there, so Microsoft's just letting me know that. Luckily, they'll accept that for me. So we now have the balance of our old loan after 8 years. Next thing we need to do is we need the new rate, which is going to be 4.5%. Have a new term, which is going to be a new 30-year loan. But the trick to this was we were only going to stay for 5 more years. So we also need to add in the costs for this new loan, which we had an origination fee and a couple other fees that were just going to be a dollar amount. So we had $800 in fees. We also had origination fees of 1% on the new loan. And we'll go ahead and get that actual dollar number from our new loan and that cell next to it. So we had total $2,369.85 of that 1%. So next thing we need to know is the payoff comparison between these two loans. Let's put this in here. And what we're actually doing is we're going to take the old loan, the information above here, compare it to the new loan, saying what would we be at in 5 years on our new loan versus 13 years, the 8 plus the 5 in our old loan. See which one would actually be a better deal for us. So we'll need to get the present value of our original loan, the first loan, our old loan. Plug in some of this information. Oh, forgot my parentheses again to make this a little simple. So we're going to do 30 years, and this is going to be minus 13. Again, that's the 8 years before we hypothetically refinance the first time, and then the amount of time between the second refinance. And again, I'm a little lazy because Microsoft always wants to help you out with that last parenthesis by the click of a button there. And let me change this to currency for a nice clean number. So that would be the amount of our old loan had we never refinanced the 8 years or the 5 years. Well, this would be for 13 years refinancing where we would be at. So let's do the same thing for our new loan. Oops, getting ahead of myself there. I need to get a present value formula open. So we're going to take our new rate, divide that by 12. We're going to get our number of periods, minus 5 years in this scenario. And I've gotten way ahead of myself here. So let me back up just for a moment because I have not even made the number for our new payment and our annual payment for this new loan. So I'll get this number real quick. I apologize about this. Be a real quick step. We've done this many times this semester, so nothing new here. Almost done it so many times I forgot I even needed to do it, right? All right, so there's our new payment. A little bit lower than what we were originally paying on that first loan, thanks to that new lower interest rate, which is probably the reason we would even take a look at this in the first place. All right, so now we can get that present value now that we have the payment in there. So again, I apologize. I don't know how I missed such an important step to this project. So we're going to get this 30 years after 5 for our refinance model. And now I can plug in our payment, which is a crucial piece to this formula. Get a little bit clearer. So we can actually see here that our old loan, had we never refinanced, actually would be the better loan at the moment. So we're going to find the exact difference here. That's a difference of $9,300 between the old loan never being refinanced and our new loan being refinanced after 5 years. So what does this really tell us? Even though we're saving some money every year between our payments, is this really a good deal in the long run? And the best way to find out is to see a present value and an internal rate of return. And we'll get those numbers up here in just a second. So today, what does it cost us today for our new loan? And that number is simple. It's going to be the origination fees as well as the upfront fees as well. So we've got a negative $3,169. This is what it's going to cost us to get into this new loan today. Okay. And then what are we saving every year? And that we can get that number from our annual payment from the old loan. And we're going to subtract out, or actually in this case, add in the negative from the annual payment. Oh, nope, did my math wrong. I apologize. We're going to subtract out and we had a difference here of 5,000. This number actually needs to be a positive because this is what we're saving. So let me just flip my numbers around here. There we go. That's going to be a much better number to work with. And that's what we're going to save every year. So I can just copy that number from the cell next to it, drag that across here, and that's what we're going to save every year. But, however, we need to add in this negative 9,315 because that's going to be the difference between the two loans after the same amount of period of time had we never refinanced with the old loan versus refinancing again or selling out at the new loan 5 years down the road. So we need to get a sum here of these numbers. Oop, nope, that's not what I needed to do. Basically, we're going to get a sum of the two columns above. And if I can get my mouse to work right with me, we're going to go ahead and do both of these columns here, even though there's nothing there. Oh, sorry. Even though there's nothing in column. Wow, I just cannot get this to work with me. We're going to drag that across for the sake of all of our rows here. So we can see the difference there in the last row. That'll save us a little time. All right, so that's the total each year, including today. And what we really want to know, what the whole point of this refinance was, to see what our IRR and our NPV are, to see if this is actually going to be a good deal in the long run, even though, you know, we're saving some money on our annual payments, years 1, 2, 3, 4, and 5. We're still losing out today with our fees. And had we never refinanced to begin with, we would be $9,000 ahead in principal payments on our original loan. So let's get our IRR in here. We're going to use the values listed above here, our totals from today until year 5. And that's going to give us a really high rate of return, 152%. Now we're going to look at our NPV just to give us another look to see if this is still a good deal. So we're going to, and this was the tricky part, this is where I had to stop and ask for help myself in class. The NPV is net present value of future payments. So we go with the future payments in our first value here. And actually, I need to go ahead and get my parenthesis in here because we're going to be adding in our today payments separately here. So we're going to add up all of these here, close out our parentheses, and add back in our future payments because these are payments now. These aren't in the future, so we need to look at that a little bit differently. That's where I want to add it in here. That's the question I had in class, and it made a lot more sense after you stopped and explained that to me. So once I hit enter here, I might get a little typo saying, hey, you didn't close everything out. But oh, okay, yeah, you can see I made a small mistake there. I've still got it a little bit wrong. What needs to happen is our parentheses needs to come out there. This is our net present value formula here. What we will be doing is adding back in our payments today on the very outside. So I was a little off there, I apologize. But what needs to happen for our net present value is our rate and the values in the future, which you can see here in the blue. Outside of that net present value formula, we'll be adding back in the payments for today. So that should actually give us the correct amount there. So this actually turns out to be a decent deal. We come out ahead in the long run on this deal, even though you can see some negative numbers in here. Well, the fees are not necessarily a negative number, but it is something coming out of our pocket, coming out of our cash flow. So that's something that we need to be aware of, as well as where we would be at in our old loan had we never refinanced and decided to say maybe sell the house after this next 5 years, or we were going to refinance again. And is there any way we could have got a better rate? Even 4% is one heck of a rate, but you know, times being tough now, you never know what rate you might be able to end up with, banks being very competitive. So it's always a good thing to know how to do this type of stuff to see if you really are coming out ahead. You know, the bank will tell you some things, but is it really in your best interest and the borrower's best interest? And I hope this example here has clarified some of that. It was a little bumpy, I apologize. But thank you for viewing this video, and thank you again, Dr. Seagraves, for everything you've taught us, especially things like this that'll help out much greater in the future. Thank you.